Today, we'll begin with classifying our solids. Classifying 3D figures, which are our solids. If you were to place these solids into two groups, what would these groups be? Great. If you said polyhedron and non-polyhedron, well done. Let's look at what a polyhedron is. Polyhedron is a solid with flat faces, which means each face is a polygon. Do you remember what polygons are? Your square, your rectangles. Those are samples of polygons. All right, so let's look at our groups. So we have our polyhedron groups, and you'd see those solids over there with polygon faces. And then you have your non-polyhedrons, your cylinder, your sphere, and your cone. Over here you'd have your cuboid, your prism. Well, your cuboid is a prism, and then you'd have your pyramid. Let's look at some nets of solids and see if you can tell me the solid that would come from each of these nets. So before we even look at the nets, let's see what a net is. A net shows what a 3D solid could look like if unfolded and laid out flat. So our first net is up. Can you name the 3D solid with this net? Did you say cube? Awesome job. What about this one? I'm sure you got it. Let's see what it is. Yes, it is a square base pyramid. Awesome. Now, as we said before, remember the net is, if you were to open up that solid and lay it out flat, that's what the net would represent. So let's look at the nets together again. So you have the net of the cube. As you can see, it's made up of squares. And you have the net of the square base pyramid, which would have a square, and it would have the triangles, which would form that top of the solid. Then you have, I didn't give you this one. Can you tell me what that is? Great job. It's a cylinder. Anyone can tell me this one? Awesome. You guys are awesome. This is a triangular prism. So these are the nets of 4 types of solids that we might be working with today. Let's explore. You are an engineer at an advertising agency. You're asked to determine how much fiberglass material will be needed to cover a cuboidal frame sign for a client who specifies that all faces must be covered or must be used. Now let's look at this a little bit. So you're now asked to use fiberglass to cover this frame. So you're out there in the world and you're awesome, you're an engineer, and you have this metal frame that you need to put some advertisement on. Now fiberglass comes in a fabric-like, roll that you'd use to stretch across this frame to now create your cuboidal awesome design. What would you think you'd need to do? What math concept would you be applying here? Yes, you would have to figure out the total surface area of that particular cuboidal frame in order to be a very good engineer in this instance. So let's look at our first cuboid or cube. And then let's look at this one. So which one of the cuboid would you use to make this sign? Yes, I'd go with the cube. So let's look at the cube. What shape are the faces that make up this cuboid. So just before I forget, a cube is a special type of cuboid. Why is it special? All its faces are congruent. They're all the same. So all the faces of the cube are squares. So it is a cuboid, but it has faces that are identical in how they look. And that's why it's a special cuboid. So as I said before, all the faces of the cuboid are made up of squares. If we're to look at another type of cuboid, the faces here are made up of rectangles and squares. Now, since we decided that we're going to use the cube to construct our sign, which our client has specified, we now need to pay attention to the attributes, to the features that make the cube unique. They have 6 congruent or same faces. We already established that. And your cuboid, as you can see here, the other cuboid has 3 pairs of congruent or same faces. So you'd have this face would be congruent to the one that we're not seeing. Remember, we said earlier that in a 3D figure, all the faces are not seen at once. So this would be congruent to this. This here would be congruent to that. And this would have a congruent face to the back of that. Hence the 3 pairs of congruent or same faces. Now, we said that we wanted to calculate the total surface area. Calculating total surface area of a cube, this is what it would look like. The area of one of the face would be the length times the width, because I know you know how to calculate the area of a square. So it's length times width, or some persons may say length squared, same. So we have A representing the length here and the width, which is the same. So the surface area of the cube would be 6 faces with the area A squared. Now, if we were to use another type of cuboid, which would be this one with the 3 pairs of congruent sides, we now have to pay attention that this length is different from this and from this. Therefore, we now have the surface area of the cuboid would be 2AB plus 2BC. So we'd have to find, so this represents the 2 congruent rectangles, which is the length and the width is BA. And for this one, the length and the width is BC. So we have 2 of these rectangles, 2 of these, and 2 of these. So in total, we have 6 faces on this cuboid, and we have accounted for all 6 faces. So your total surface area has to do with finding the area of each face and then summing the area of all the faces of that solid to give you the total surface area. So what did we do again? We looked at some nets, remember? We looked at the nets and we talked about how these nets were made up of polygons and how these nets came together to form solids. Good, and today we're looking at total surface area. What is that again? It is all the area that is covered on a solid. So if you can see, remember when I was trying to show you on the diagram on the screen how this type of cuboid had 3 pairs of congruent faces? Let's look at it a little bit more. So this face is A, that means this face is also A. We have a B face here. We have a B face here. C is here. And we also have a C here. So let's make that C correct there. So you have 3 pairs. My fingers touching a pair. My fingers are touching a pair here. And my fingers are touching a pair here. So we have 3 pairs of congruent faces. This one is not a cube, but it is a cuboid. So let's see. So that explains why we have, this one would be, well, if I had to label the sides. So since I didn't label the sides, it would be this side, multiply by this, because you'd have to go back to your fundamentals where you now look at the area of this rectangle or square, whatever that shape is, of the face. So you'd have to remember those fundamental concepts that you would have learned prior to total surface area. So we're going to look at another activity. Now, you're a party store owner, recently purchased a cylindrical gas tank to store helium. You know how it is. You have lots of balloons and you have to have your own helium to make sure that when they come for their party stuff, you are able to fill up all your balloons. You are hired to paint. So you're not the owner. You're the person who is now hired to paint that helium tank because the owner refuses to waste his or her money. So to prevent rusting, you're going to have to install this tank, but you're going to paint it first. What would you need to know about the tank in order to purchase the minimum amount of paint to cover all the surfaces of the fuel tank? You thought about it? Awesome. So tell me what it is. Yes, of course. The total surface area of the tank is what we need to consider. So, as you know, a cylinder, which this looks pretty much like the tank. So the cylinder has this curved surface, and it has what? As you can see, it has, if I were to set it like this is a circular face and another circular face. So it has circle for this face and a circle for this and this curved one. Now let's look at this question a little bit more. Do you know how to calculate the total surface area of a cylinder? I know you do. But first we're going to look at the net. Let's just look at it together. Let's look at the net of this particular solid. As we pointed out before, it consists of two circles. And if I were to cut one side and open it up and lay it flat like what we said initially, we would have had a rectangle. So the shapes that we're working with for this solid are circles and a rectangle. As I said, your fundamentals, your basics will have to come into play now. So you'd have to know how to find the area of a circle and the area of a rectangle. Now, very, very important, when you open up this net, you will realize that the circumference of the circle is also the length of one side of your rectangle. As you can see here, the length of the rectangle is equal to the circumference of the base. Now, what do you use to find circumference of a circle? Correct, 2 pi r. We look at 2 pi r, so 2 pi r now becomes not only the circumference of that circle, but it is now one of the sides of our rectangle. So the width of the rectangle is the height. So I'm closing up back my net. It will look like this. The height would be this measure here from the base to the top of the solid. So that is our height. And as you can see, the total surface area of the cylinder would be the area of the circle on top, the circle on the bottom, plus the area of the rectangle. And your area of a circle is pi r square. So you'd have pi r square plus pi r square. And then the area of the rectangle, as we mentioned before, one side would be 2 pi r, which is the same as the circumference and the height of that cylinder. So if we were to simplify what we have here, we would have 2 pi r square plus, because we have pi r square here, plus another pi r square. When you add those, you'd get 2 pi r square plus 2 pi r h. And if we were to factorize what is common between these two terms, our expression would be 2 pi r, and what we'd have left is r from here and h from there. So this now becomes your simplified formula for finding the total surface area of your cylindrical gas tank. So, just to let you know, total surface area is practical, it's real. It just depends on what you'd want to find out in real life. So, I know a lot of times we think that, math is abstract, but math is very practical. And every concept has its place. So total surface area could be used if you were a painter. As you can see here, this is just now to let you see exactly where we're coming from. Your radius is here, and you would have been given these, or you'd have been asked to determine them depending on the question. Now, just for those who are just joining, let's look at what we were doing before we left. We were looking at total surface area. We were looking at how to find the total surface area of solids. And we would have said that we'd need to identify the faces of that solid and then determine the area of each face. And it is a totaling of all those faces that would give us the total surface area of a solid. We also spoke about how practical and meaningful it is for engineers, for persons who decorate things that are solids. So they would have to be able to determine the total surface area in order to purchase material. So those are just some of the applicable ways in which the concept of total surface area can be used. Even if we're looking at total surface area for a plane shape, we would look at for a two-dimensional shape, for instance, your floor. How many tiles would be used to cover this floor? Has to do with the total surface area of that two-dimensional shape. However, let us continue and look at activity 3. Now, this is a sample question from the CSEC curriculum. We have 2 diagrams here. And as you can see, the diagrams are cylindrical. So let's read. The diagram not drawn to scale shows 2 cylindrical water tanks, A and B. Tank B has a base diameter of 8 meters and a height of 5 meters. Okay, I don't really want you to see that yet. So let's look at it. If you were asked to find the total surface area of this cylinder, of cylinder B, what would you do? Remember what we said? We said that in order to find the total surface area of a solid, we'd have to determine the faces that are there. Remember earlier we looked at the net of a cylinder. Can you tell me how that net look again? Good. So we'd have, not drawn to scale, but we'd have a circle, and we'd have a rectangle. So, and we'd have another circle, that's correct. So we'd have the top and the base of the cylinder. We'd need to find the area of the circle. Who remembers how to find the area of a circle? Great. So the area of a circle can be found by using this formula. That's supposed to be a 2. It looks a little bit weird. Let's change that. So 2. Now on the question, normally the pi, what the value of pi is given. So we're going to use pi to be 3.14. So if we're using pi to be 3.14, we'd substitute the value. Now, what is the radius of this? Remember, it's B, so B has 5 for the height and 8 for the diameter. So what is the radius in this case? Remember now, the radius is half the diameter. So we know that if the diameter is equal to 8 meters, then the radius is correct. It's 4 meters. It's half the diameter. Great. So let's substitute. So we'd have 3.14 for pi, and we'd have to multiply the radius by itself because that's what that square means. So we'd have 4 meters. Whoops, that's not 4. That's 3. 4 meters multiplied by 4 meters. So we'd have, that is how we find the area of the circle. What would that work out to be? So we know 4 times 4 multiplied by itself is 16. So we can rewrite it, or we can do all the multiplication at once. So this would be 16 meters squared. And area is measured in a squared unit. So we'd calculate that and we'd get that there, which we'll do shortly. So we will find, so we have the area of, we're not even going to do this. I'm going to show it to you in total, but for now, so this would give us the area of one circle. But we have how many circles in this particular solid? We have 2 circles. Therefore, we're going to have to give you 2 multiplied by whatever we're going to use for one circle. And that would give us the area of the circular part, or the circle faces. Let me say it correctly. The circle face, the circular faces that we have, this would have given us the area for that. But that's not it all. That's not all. We now have this curved surface that is opened up into a rectangle. And for this one, remember what we said. This length is also the circumference of this. So how do we find the circumference of a circle? We can use 2 pi r, or we can use pi d. Correct? So, and then this length would have been our height. So because it's a rectangle, we know it's length times width, or side multiplied by the other side, or the right. So let's go 2 pi r, and we're going to multiply that by height. And we would substitute the values into the equation again, or into the expression to give us the value that we're looking for. So we put that multiplied by the radius, and the radius is the same, multiplied by the height, which is, we're given the height to be 5 meters. So we now multiply. It's only one rectangle. So we'd add what we get here and what we get here to give us the total surface area. So now let's look at it. Oh. That is if you are finding the area of the entire cylinder. And so let's write up what our total surface area is. There is a shorter way to write out total surface area, which I'm sure you guys are aware of. We tend to write TSA. So where TSA would equal whatever this works out to be, the value of this expression. Whoops. So we'd have 2314.4, or pi value, multiplied by 16 meters squared, plus, so we're going to put this into a bigger bracket, plus the area of the rectangle, which can be calculated using these values. 4 meter multiplied by 5 meter. And when you sum those two, you'd have gotten your TSA, which is your total surface area for the cylinder. Now let's look if you're given something else. So if you're given the area of A to be 314 meters squared, calculate the length of the radius of tank A. So we just worked out the total surface area of tank B because we're given the diameter and we're given the height. So we're given all the lengths and the measurements, for that cylinder, and we could work out its total surface area. Now what if you're not given the measurements, as you can see in diagram A, but you're given the area of the base. Now remember, the base is a circle. So I'm going to take this off the board. Give me a minute. There you go. We're going to take this off and we're going to look at what the area so you're given, this is fine. So you're told that the area of the base, remember what the base is? What shape is the base? The base is a circle. We're just going to put it in bracket here. The area of the base is equal to 314 squared meters. Okay? So what is the area of the base? It is 314 squared meter. What is the formula? How do we find the area of a base? Of the base of a circle? It is pi r squared. What do we do here? What are they asking us to do again? They're asking us to calculate the length of the radius. So the r in our expression here would represent the radius. So we have, if we were to plug in all the values over here, it would give you this value. So we can now equate it and we can transpose for r. So we're going to transpose. We already know that the value for pi is 3.14. We don't have a value for r. We place it back. That's not right. It's 314 squared meter. Excuse me. Now let's look. So what is happening to this r squared here? It's been multiplied by 3.14. We want the r all by itself because we're trying to make r the subject of this equation. So the opposite of multiplication, as what is being done here, now is division. So we are going to divide both sides by 3.14 because we want r all by itself. We want r to stand on its own. So 3.14 divided by 3.14 gives us 1. 314 square meter divided by, whoa, yes, divide by 3.14 will give us, yes, it's 100 meter squared. And now this is equal to r squared. Is it r squared that we're looking for? No, we're looking for r. So we'll have to find the square root of both 100 meters squared and r squared. The square root of 100 is 10. The square root of m squared is m, which equals to r. So r is plus or minus 10, as you can see on the screen, or 10 meters. For those who are just joining, we would have looked at what you need to understand about total surface area. It is the coverage of that space. So you need to figure out, we're looking at calculating or determining the total surface area of solid figures. In that case, we'd have to make sure that we realize what type of shape are those solids made of and how to calculate the area of each face that you're interacting with. We looked at the difference with a cube and a cuboid. Your cube would have the faces that are all congruent or all the same. Therefore, if you worked out the area for one face, you'd pretty much multiply it by 6, or you could add them 6 times. While another cuboid, which has 3 pairs of congruent faces, you'd pretty much figure out what the area of one face is, and then multiply that by 2 for the 3 pairs that you'd have. All right. Now, we're going to do another sample question, and then let's see if we can get through it. So, this question says, a farmer constructs a storage tank as shown in the diagram. The slope of the tank consists of a cylindrical body of height 3.5 meters and a diameter 8 meters, and a conical roof of vertical height of 1.2 meters. Now we're using pi, as we were previously using the question before, as 3.14. So you're asked to calculate the slant height of the roof of the tank. As the farmer wishes wishes to cover that slant distance with something. So how do you think you'll calculate the slant height of the roof of the tank? All right, so the first thing we want to look at is exactly what the roof of that tank looks like. So we're looking at a cone, and we're trying to determine the distance from this point here, your apex, to the base of your shape, as you can see there. So remember this Pythagoras theorem. If you were here, if you have been with us from we started, you'd remember that in order to access total surface area, there are some fundamental concepts that you must know. We looked at the area of plane shapes, and now for this particular problem or question, we need to understand what Pythagoras theorem is. Now, Pythagoras theorem states for all right angle triangle, there is a relationship that exists with the three sides. That means if you were to square the hypotenuse, which is your longest side, it would equal the sum of the square of the other two sides. So we have to understand Pythagoras theorem in order to access this particular question. In this case, L, as you can see, would be our hypotenuse. And then your other two sides, we are going to look at what we use. We are using V for one of the sides, and R, which symbolizes the radius here, because this distance is the radius of the circle that we're working with. As you can see, the diameter of the circle is given to be 8 meters. And remember, we already said that the radius is half the diameter, or the diameter is twice the size of the radius. So the radius is there. So you'd square the radius and you square the other side. That is your vertical height, represented by V, which is 1.2 meters. So we'd substitute the values in this equation here. So your V being 1.2 meter plus squared plus 4 meters squared will equal your the square of your vertical length. And if we were to square them, you'd have 1.2 squared is 1.44 meters, squared meters, and 4 meters squared is 16 squared meters. And then you were trying to determine what our length would be, our vertical height, our slant height. All right, so we'd add these, we get 17.44 equal the square vertical length. Height, so height is the same as the length there. Now to find the slant height, we'd have to find the square root of L squared and also the square root of 17.44 squared meter, which would give us 4.18 meter, which would give us the slant height. Let's go through it one more time for those who probably didn't follow through with me initially. We would need to know Pythagoras theorem because there is a right angle at the top here. That's what we're using to find the slant height. The slanted height represents the hypotenuse of the triangle. And we'd sub, pretty much, we have found the slant height. And then this part now would take us to show the total curved surface area of the tank to the nearest meter is 140 squared meter. Now let's discuss this a little. What is a total curved surface that we're looking at? So for this particular shape or solid that we're looking at, you'd have this curved surface here. Let's make the shape for those who are very visual. It's pretty much this. And we're looking at this curved surface along with this. So what I want you to realize is that we're not capturing this circular face, neither are we capturing this. So we need to determine this area along with this area. So the area of the curved surface of the cone would be pi multiplied by the radius multiplied by the slant height, why we needed to calculate that in the first place. And then we'd add it to the area of the curved surface of the cylindrical tank, which is here, which is 2 pi RH. We're given H, and we know what the R is. We are also given the radius. So we pretty much can substitute those values, and this would work out to be 52 squared meters, and this would work out to be 88 squared meters. Adding those together, 140 squared meters. Several persons require this skill of knowing how to calculate the total surface area. So remember, when you're finding the total surface area, which we commonly call the TSA, of any solid, you need to consider the faces that make up the solid. Let us have a look at my desk to see the solids that we're looking at. So for your cone, you have this curved surface plus a circular one. For your cylinder, you'd have 2 circular faces and your curved surface. And remember, we said that these are what? These are non-polyhedrons because they do not have, all their faces are not polygons. Then you have your cube, which you'd have to look at, your square faces. And you have, this is a cuboid, which we have rectangular faces. They're all rectangular. I'm not seeing any square here, but some cuboids can have a square face, pretty much like this one here. And you'd have your hemisphere. This is what? We didn't even look at this, but what is this? This is a pyramid. This is your square base pyramid. So you'd have to figure out how to find the area of your triangular face. You'd have to determine, well, count the faces that you have. So this is 1, 2, 3, 4 faces. As you can see, there's a face from each side of your base. You'd have to figure out all of that. And this here is a sample of a prism, which is a triangular base prism. And you'd have to figure out the face, which is your rectangular face, and your triangular face. When you figure out what face make up the solid, you would determine what is the area of each face, and then you'd sum these faces in order to give you the total surface area. That is all the area of that solid. So we do thank you for tuning in. We hope that it was beneficial to you, and we do hope that you join us every morning around the same time for different content on things that are most helpful to you as a student and maybe even to adults who are pursuing math.